Okay, so I decided to record how I solve Edo 104. I didn't make it to the live version of the contest, so I'll have to do a virtual round now. And before we go, let me fix some settings because video is a bit off at the moment. Yeah, it's good, it's good. Should be good now. Okay, so problem A, arena. Okay, we have n heroes. We have n heroes fight against each other in the arena, and it shows the ice hero has level AI. Each minute a fight between two different heroes occurs. These heroes can be chosen arbitrarily. It's impossible that it's the same two heroes that were fighting during the last match. Okay. When two heroes of equal levels fight, nobody wins the fight. When two heroes of different levels fight, the one with a higher level wins, and his level increases by 1. I really should turn off my notifications beforehand. Okay, so the winner of the tournament is the first hero that wins in at least a huge number of fights, okay? It's possible that the tournament lasts forever if no hero wins this number of fights, then there is no winner. Calculate the number of possible winners among n heroes. Okay. We have multiple test cases in this problem. Now that we read the input, we can actually solve the problem. And I believe the solution is like, if the hero is not the lowest level, then he can just win the fight with the lowest leveled hero, like repeatedly until he wins all the fights in the world, right? So we effectively want to say how many values are not equal to the minimum value, right? And so let me actually grab minimum. It is going to be a min element of a begin, a end. Then I believe I can just count minimums and subtract them from n. And this is going to be it. Yeah, okay. Yeah. Did I not print anything? What actually happened? Oh, because this was the wrong file. Right. 103. Yeah, I actually think this is correct. Like, there's not much to this problem. You just kind of... Yeah, 2,000 people already solved it while we were setting up. So we are not particularly quick here, but at the same time, yeah, good. But at the same time, we are not like terribly slow, so we are fine at that moment. Problem B, cat cycle, really should have been problem C. Well, okay, we don't have that freedom of choice in this problem. Yeah, and because it's like a virtual contest, not a real contest, you can't see me getting distracted a bit. I think it's okay. Yeah. Yeah. So we have, suppose you're living with two cats, A and B. Well, I would have been more inventive with names, but it's okay. There are n napping spots where both cats usually sleep. Okay. Cats like to sleep and also like all the spots. So they change napping spots each hour cyclically. Cat A changes its napping place in order n minus 1. Okay. At the first hour, it's in spot 10, and then it goes decreasing the order cyclically. Okay. Cat B changes in increasing order, but Cat B is much younger, so they have a strict hierarchy. If you don't what? Okay. Yeah. Uh, don't lie together. It means that like B skips, I suppose. Yeah. B skips. Uh, yeah. Okay. Where cat B will be at our K. Well, because K, like first thing you should notice is that K is relatively big, so you can't just simulate. But other than that, it sounds like a math problem. Well, I guess it's not particularly difficult. Let's figure it out. Some meaningful examples can include like, well, actually 69 and no, we're not going with that example first. It's a bit too long to draw. Maybe we can figure out something like this. Suppose we have 1, 2, 3, 4, 5, right? First thing you can notice is like if n is even, they don't really interact. So you just get to output something like k mod n plus 1, I guess. Something like that. So we are like really interested in the case n is odd. Right, because now let me actually shrink this and put it somewhere here. So if n is even, then you output something like k modulo n. If n is odd, then interesting things happen. In the first hour, he's here. In the second hour, he's here. In the third hour, there are both here, so he skips. The fourth hour, he's here. In the fifth hour, he is not here. He skips again. So in the sixth hour, he's here. In the seventh hour, he's again not here. He again skips. So it looks like he skips in every 2 moves, and 2 is because like if m is 2m plus 1, he really skips every m moves. So it's like he moves m plus 1 places per m units of time. So you really want something like m plus 1 times k over m. Something of that order. Yeah, I'm thinking it's more or less like exactly what we want. Maybe plus or minus 1 in several places. So here we have odd values of n, here we have even values of n. Now for even values of n, k gets modded out by n. If not k, however, we want to set k to n, right? It's not like +1, it's just this particular case when you got an OK. K is divisible by n, it means that you end in the last position. Am I right? Am I actually right? Or is it like the R is 0 and we want? Nah. The R is like exactly what we want. So here we just output this. Here, however, we would like to take m. Now, what we can do is we can take like quotient and remainder of k divided by m. Let's quotient is how many full cycles of that m we experienced. And apparently k should get q times m plus 1. I'm thinking plus r, right? You got to be careful actually here. I don't want anything to overflow. So I'm guessing it's safer to do it this way. And then you again want the same thing. So yeah, basically like this you can do no matter what. Yeah. I'm pretty confident that's what we want. But let's actually run tests because penalties are quite severe here. Just for 1 hour, okay. Yeah, like I kind of don't want to turn on the notifications about work, but I think I can. Yes, I absolutely agree. And I also forgot this optimizations flags. I recently discovered that like tuples work really slow if you don't turn on the optimizations, which is interesting. Like if you turn on the optimizations for tuples, they basically like gets into separate values assigned in the correct order. Like we saw this like temporary variables being explicit, integers and not tuples, which is much faster. Okay, so something does not work right. For example, third test, we have 3 and 1. And we really should be at place 1, right? But it says 2. Oh, that's interesting. Yeah, what I'm thinking we want to do is like we actually want to make this and to make this in the end. Yeah, it looks more or less reasonable. Yeah, I think so. I think it's okay. Because like we're interested in actually how many moves starting from the first happens, I guess. This is the reason. But let's see, maybe I'm still wrong. No, I'm correct, yes. So problem C, minimum ties. Big football championship will occur soon. Cool. Will it actually? Do they have some sort of world championship? I'm not sure. I thought like the no, we should not have like maybe year 2022. I don't know. And teams will compete in it, and each pair of, or maybe they mean football, like not soccer, but American football. I don't know. And each pair of teams will play exactly one game against each other. There are two possible outcomes of a game. The game may result in a tie in both games. Yeah, we know the soccer rules. The score of the team is number of points it gained during all games that it played. Reasonable. And you're interested in a hypothetical situation where all teams get the same score at the end of the championship. A simple example of that, even all games result in ties. But you want to minimize number of ties as well. Okay, so we want to minimize number of ties, and at the same time, we want all teams to get the same score. Oh, but make sure, like if number of teams is odd, then we don't need any ties at all. And if it's even, I'm assuming we need at least n ties. That's a terrible output format. Yeah, it's more or less clear what you want to do. Just it's going to be quite annoying. So what I'm thinking we can do to ease our suffering a little, just create actually like a result table. Have a result table. To look there. Yeah, like because we created in a nice way, I'm going to fill it in somehow. Okay, but what I really want to do is like I actually want to print the results. Once one, two, once. Okay, I got it. I think I got it. I plus one, I believe. This is actually like our output, no matter in which way we fill in the table here. Well, results in the correct output order. Now we have two cases when n is odd and when n is even. So I'm thinking in a case when n is odd, we can actually result without ties, like arrange all teams around the circle, and then just let me actually remove that. Now let every team win the matches with the next half and lose matches to the previous half. Like, no matter what team you take, there will be previous half and next half. I'm not going to draw it because I think it's actually relatively clear if you draw it yourself. So, in case of even ends, I assume it will need I'm going to do it this way. You don't really have to tie all conditions into one variable, right? yeah, it's completely fine to have something like this. Now I think we say aij equals 1. This thing has actually 1. Oh, actually, yeah, but now we're going to say that this team actually lost, right? We should not have any collisions because AAJ corresponds to the from the perspective of I's team, which is exactly what we want. And for this case, we're going to do like exactly the same thing, with the only exception being that here we actually want to say AIJ equals E draw, and J gets G plus 1 mouse N. I'm assuming this is exactly what you want. And the only difference is that we are going to test it on more test cases, because like 2, 3 is just go. If you don't get any information useful, and so 17 and yes, and here. Right, because I'm not very smart and or actually I'm not sure what is the, I think this should be fine. This clearly should be fine, and the other version I'm not entirely sure. So this is already incorrect. And I'm thinking because here we actually want one less gap. Right. Because like if we have 2 teams and we don't want 1 gap to be, like the half is 1 less, which is this. Let's think what it means. Like we have 4 teams. First wins from second, draws with third, loses to fourth. Second wins from third, draws with fourth, and third wins from fourth. Yeah, I think we are good. Maybe we are not, but I think we are good. Let's wait and see. Should I refresh it? Oh, okay. Problem DP Pythagorean Triples. And I'm assuming that this, yeah, we have 7 problems, right? So we should be able to solve like 5, 6. I don't know about 7. Yeah, maybe like 5 should be definitely in reach. Yeah, I should not get distracted by memes. We have a contest, but it just happens. Like it's not official, so I don't really care. And at the same time, it's allows you to focus like purely on solving problems. Not thinking about trading and other stuff, which is really useful for training. In Pythagorean, I'm not sure. Let's actually learn how to translate. No. I did not mean to. Pythagorean. I'm pretty sure I pronounce it awfully wrong, but Pythagorean sounds more or less okay. Pythagorean triple is a triple of integer. Sounds captain all this of integer numbers a, b, c, such that it's possible to form a right triangle with the length of the first catetus, the second catetus, and the hypotenuse equal to a, b, and c respectively. An example of Pythagorean triple, Pythagorean. So it's like Python, but then Pythagorean. Interesting. Is 3, 4, 5. Yeah, we all know. And another example is 5, 12, 13. So Vasa studies the properties of right triangles, and he uses a formula that determines if some triple is of integers is Pythagorean. Yeah, you just have to check a squared plus b squared equals c squared. I've forgotten the exact yeah, he forgot squares. Okay. Yeah. Oh, so it actually works. Lol. Okay. But then it's not symmetric, right? Oh, interesting. That's actually an interesting question. But then again, mass forces, I don't really know if this is what we should be. I mean, I'm assuming that there are going to be some smart way to optimize it, like to work in square roots of time. Looks like square root time. And he does it exactly in this order, right? Yeah, he does it exactly in this order. Okay. Well, that's going to be interesting. What actually happens next? Like the correct formula is always a squared plus b squared equals c squared, and the incorrect formula in our case is a squared minus b. Suppose that we change a squared in the incorrect formula, so we have like this formula. This is formula 2. And then we substitute 1 into 2. Like this into this. What do we get? Like obviously we replace a squared because it's the only term that is common. And we replace it with c squared minus b squared probably. So we should actually end up with b squared plus b equals c squared minus c, which decomposes nicely as a product of b times b plus 1 and c times c minus 1. And these numbers are like pretty equal, because if they are not, then you're done, right? Yeah, like this is the same thing. This is the same function. X maps to x times x plus 1 at b and c minus 1. And I'm thinking that on positive integers, it should be like if you take second derivative, it's clearly convex. Right? And if you take first derivative, then it's positive on integers, so it's monotonous. Function that this function never takes to one value 2 times if you plug in positive values of x. So we clearly want them to be equal. So we get b equals c minus 1. Then the question is like, what can a be? What can a be? So because we know that, and we know that a squared equals a squared equals b plus c, which is like always possible actually. If you take b and substitute here, maybe you take c equals b plus 1, then you get something like 2b times plus 1, which means that a is odd. And then c is, what is c actually? Like c is the largest number, that's why we care about it. And c is a squared plus 1 over 2. This should not exceed n. So clearly a is the smallest number, b is like a bit greater. Except for maybe like the one case when, yes, a should be greater than 1. Because if a is equal to 1, then we get like b plus c should be equal to 1. From here we get b equals. Wait, do we get b equals 1 and c equals 0? Let's. No, we should get c equals 1 and b equals 0. Yeah, and b can be equal to 0. So a is greater than 1, a is odd, and c is, and this number should be at most n. So the alternative way to express this condition is a squared is at most 2n plus 1. Just say like, okay, now a is equal to square root of this number at most. And then you count odds in, let's say, from 3 to this square root, right? Which is actually like you discard two numbers, you take the difference, should be 2n plus 1 minus 2, and then you just divide the same by 2. I'm thinking we are pretty secure with this kind of formula. Should round down, right? It should really round down. Or maybe I should add this to my, yeah, it's just like much. Did I mess up? Yes, obviously you can't do it like that. Let me actually think, not so, and yeah, it should be good, but like, you never can be too secure. That's incorrect. For a value of 6, for value of 6, let me think, if this is 5, yeah, maybe we just want 1 here. Well, that's correct, but you can't obviously let it go just like that. Not exactly sure what we should test here. Maybe we should test n equal to 1. Actually, yeah, now that I think about it, we should test this kind of thing. So if n is equal to 1, then we obviously got 0, because even for 3 we got 0. And then for 11, we still got 1 triple. It's actually right, like for 11, I think it's correct, but let me check now for 13. For 12, I should have really checked for 12. I'll start from the bottom, and it's John. Because you take it here, you get what? You get 25. Now it means that you can take something like 5 and then 20. No, wait. 5, 11, and 12. I'm not sure, actually. Oh, it should be like this, right? So, right. And now it should be good. Like we should get 1 here. Yeah, and if we take 13, then we can take 5, 12, 13. That's actually genius, right? No, it's not just like a nice coincidence. 5, 12, 13 is the correct tuple. Because then we get like 13 is equal to 25 minus 12. Should I worry about any precision issues? I think a square root is actually pretty secure. I don't think I should worry. I mean, the worst case scenario, I can always write a binary search that searches for a square root. This is like not really a point of this problem, so I think it should be good if we just admit this. Let's see how it goes. But I know nothing about square root. Yeah, okay. But I know nothing about square roots, so in case, don't cite me on this, okay? Maybe it's imprecise, but I think it's imprecise, like starting at values of n which are greater than we have in this problem. But like for n up to 10 to 18, you probably don't want to take square root, like just like with a library function. Pum, 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 pum. Okay. Now we have a cheap dinner. And before we go, because it's not an official contest, we can look at the standings of our friends, including unofficial. Oh, I'm actually faster than this girl. Interesting. Yeah, if he had a rare submission, must have hurt a bit. Yeah, I'm actually like today I'm training, practicing this really cool girl. She must be like top 2 in Ukraine, I guess. So she's kind of cool. Unfortunately, she does not have like a YouTube channel, but sometimes I think she definitely should. But not yet, not yet. So I have problem eat cheap dinner. Ivan wants to have a good dinner, and yeah, I understand it's really tricky to pronounce like Ivan, but people in Eastern Europe will be extremely grateful if you do it like Ivan and not Ivan, and not Ivan. I actually heard this once. I just laughed. So Ivan wants to have a good dinner. Good dinner should consist of a first course, second course, a drink, and a dessert. Good taste. I mean, I usually have like something random for dinner. So yeah, that's really good. And one different types of first courses one can buy. The eyes of them costs AI coins, and two different types of a second. Yeah, okay, I got it. Some dishes don't go well with each other. Understandable. Like cucumbers and milk don't go well together. There are M1 pairs of first courses and second courses that don't go well, M2 pairs of. Okay. We don't have like any sort of transitivity, which is suspicious. But anyways, exactly one. Okay. Total cost minimum as possible. Okay. I don't know what to do, but it should be doable. Um, yes, the naming convention for this problem is pretty awful, but sometimes we got to do what we got to do, and this is the case. That should have been C. Okay, so now it looks like we are reading input, half of the input actually. Yeah, there's a lot of input. Okay. And is like the thing about this problem is not that you have to do something smart, it just you have to. You just have to deal with this stupid amount of input that they give you. They don't even have like names. They just call it X, I, Y, I, and then they don't care about M2, M3. So they just like, I'm guessing before this, like problems were pretty easy. So they must have placed it here because it's pretty annoying. Absolutely annoying. But it's not a big deal. Like we are going to solve it, I'm pretty sure. Should I? No. I'm just going to use that terrible naming convention all the time. And now, just like that, with no more than 20 lines wasted for input, and I mean literal 20, like from line 26, subtract 6 lines, get 20 lines of input. We finally read it. At least we don't have test cases. That would be absolutely savage. Like I'm guessing the actual solution to this problem is like at most 20 lines long. And maybe 30, but not much. If it's impossible, we have to output make the map. Okay. I think it's actually possible, like no matter how many lines of or how many dishes you have. But it did not want to overcomplicate it even further. Because it would be like two-dimensional vector factors. Yeah. It's a no. I actually like this way. It's more annoying than the other. No. I'll just leave it as it is. first example is like this. And what do we want to do? What are the bad pairs? Let me draw bad pairs. Okay. Like we already see that we want to do this. So otherwise it's just possible to keep track of what is what. So we have 1, 2. Wait, actually, yeah, 1, 2. And 1, 1 don't go well together for whatever reason. Then we have 3, 1 and 3, 2 don't go together. And we have 1 and 1. So what I'm guessing we can do sort of DP just like that. So teach, so we're going to start with what is the cheapest way, what is the cheapest like prefix of a dinner. So here the cheapest legal prefix is 26. So the answer would be 8, and here it's 7, but here it's 8 because you can go from 1 to 7. And then it's kind of not obvious what we want to do. Clearly you can't just have all these transitions in your graph, it's just too much. So you gotta like process the pairs somehow efficiently. And yes, and it's not difficult if you think about it. So let's see. And just by hand, what we can observe here. Like 8 can deal with 7. Like we actually, for each vertex, we want minimum element in this row, except for band elements. There are not that many band elements. So maybe we can just throw this stuff into multisets and then just like erase something and then add it back. Like it has logarithmic overhead and pretty bad constant, but it should not be an issue given our knowledge. Like, I don't know if there's a linear way to do it. It's unclear. It's unclear to me what would be the linear way to do it. Because you want to calculate the minimum on, like you have this set of prices, of prefixes, cheapest prefixes that end in this part of the dish, which course, or whatever. Then you exclude some subsets for each of them. And you have to deal with this. It's just, I don't know. I think multiset should be fine. I know that there's a lot of operations to it. There are like 600,000 operations with multiset, but isn't it? Yeah, 4 seconds, man. What are we thinking about? We are done with this problem. We just have to implement that clearly. There's no way like Codeforces actually asks for a linear solution versus n log n. This is not an interview problem, right? So good to go. Now, we are almost good to go. We would like to put it actually like that, I suppose. And then we don't want this. We want something like a while in 1. Empty. And because we kind of want to process the edges of a graph as we go. So we want to group them by vertex, and this is exactly the reason why we are going to Why we're going to name this graph? Oh, actually, I recently figured out that the correct spelling is graph, and in British should be like graph, graph. I don't know. I don't know, but they say so. So graph 1 at x should add y to it. And we actually should have like xy defined here, here, and also here, and also here. Total mess of a problem, if you ask me. So you know what's coming. That just, yeah, you got to do what you got to do. We're here not to what is the word? Complain about problems. We are here to solve them, right? So what is actually I think this is reasonable upper estimate because all prices are up to 10 to the 8 and we only have 4 of them. So I think with this we should be good. Now the only thing we have left is to do this stupid thing. And even more annoyingly, like you actually you have to process the first layer and the last layer sounds a different way. Although you can make it like DP0 and work with it, but it's just full. I don't know who's author of this problem, but well, pretty technical, I would say. There are, in my opinion, better ways to make a problem than just this mess. I think it's insert. Okay. I actually should make it here. Oh, complete madness. I think there are better, like more generic ways to do it, but at this point, I don't want to think. I just kind of want to implement it, right? And then I don't think ever about it ever again. I guess this is what you can say. So for, oh man, that is, it's actually the first error that I made. The first mistake was that it is actually has to have a size not of edges anymore, but of vertices, and then not from here to here, but from here to there. Because we want to know who is Ben's ancestor, who is bad parent, right? So I1 in G1, I2. What do I actually want to erase? DP1, I1, I think. Then we want to add it back. Intellectual problems where you have to do everything with multiset. Very non-trivial logic. Of course, I'm kidding. It's just like not the kind of problem I would like to see, but it happens. It's a time limit kind of says like do whatever you want, just solve this stupid problem. Also memory limit. Yeah. Oh, that's an interesting question. Nah, not very. You just trade cost of can if and the pizza at item gets not expected. Who would have thought? Who would have thought? And then you have to copy paste this loop twice and actually this loop. Make sure that you did everything right. Because if you did, and then you're going to suffer a lot. I mean, a lot. When debugging this, of course. At this point, we basically have to increment everything. Every stupid literal by one. Oh, actually, yeah, I'm starting to lose it. Now we want to increment by 2, right? No. Yes. Expected answer is 26. And our answer is that we crash. Oh, okay. Oh, obviously. See, copy pasting is bad, but at the same time, in problems like this, like what is the adequate alternative? To generalize for them? Nah, not gonna happen. But this is actually incorrect. We want IT. We don't want to reference just this. We obviously want to add the item. And here we want to add CI3. And here we want to add DI. I'm pretty sure it still fails, but let's see. Yeah, okay. Okay, let's just do binary search our code over our code. No. I almost accidentally opened Visual Studio to debug this thing. I don't want to. Huh. Also, these are different. Come on. Like, so you see, like here they get they give all of this on the same line, but then M1, M2, M3 on separate lines. Who are you to do something like this? This is unacceptable. In particular, because I have to rewrite my code because I can't read. Like what? Really, Codeforces, do you assume that you're this is not what you think? It's difference. So Codeforces apparently with this kind of statement assumes that their users can read. Now, I don't know about you, but I can't read. Like, it's not a reasonable assumption to make. So at least now it is not crashing. Okay, that's already pretty good. And it even produces a correct answer. This is not what I thought. This is what I thought. Yeah, no, the reason is clear. And because previous iterator is infinite. I think here we are safe to assume that this happens. It does not happen. And then here we can do it like this. Yeah, I kind of can just change the sign, but I want to make sure that it doesn't actually end up doing anything wrong. Should see 26 and then it should be it. Please tell me that the tests are not like awfully long. Am I actually going to get TLE because I did not figure out the linear way to do it? Nah, I should not. What the heck? So you have to optimize it somehow, clearly. Because multiset is not fast enough. Interesting. So you tell me that there's a cheaper way to find this minimal. What is it actually? I'm not sure. I'm not sure. Let me think. Yeah, but no, like for different numbers, or maybe different things here to do. It's actually not clear why this does not run fast enough. Because like it actually does like No, okay, it does like 1,200,000 operations with multi-sets. This does not fit in 4 seconds. Is there any way we can optimize it like cheaply? Because I'm not really into looking for a way to like get another solution. No, it actually makes more operations with multi-sets, right? Yeah, like the constant is bad. Here you clear. Here you clear, right? What if you don't? And you just create new sync. It's going to lead us to actually rewrite some of our codes. For example, here you want if it's greater than this, and you just greater or equal to this. What if we just do some like stupid optimizations? This is like a lot. You have to find first, and then you have to erase it. At the same time, you have to add them back. I don't know. It's just like the constant. Really, it's. It feels like it's not the purpose of this problem. That's what I'm trying to say. I don't think that we changed a lot, actually. I don't think that we really changed anything. Like, look, we still have 1, 2, 3. Well, this is all of 1, so it does not count. 1, 2, 3, 4, 12. No, actually 4 times 200,000 times 3, which is a mad number of operations with a multi-set. At the same time, it's not obvious what else is expected, to be honest. Maybe we don't want actually to have all this in 60/40s. Just trying to make error. Well, it's actually hard. Like all numbers should be small, right? Then four numbers like this do not actually fit, right? Because imagine that it's like the second state is not. Oh no, if second state is not reachable, then the third state it won't get like 2 millions, 2 billions. It will get 1 billion plus west. So it should be faster, but I'm thinking again. I don't really know how to measure all this performance. Optimization code. Not really like a terrible optimizator, to be honest, because you clearly ignored that part. Yeah, I'm assuming. No, actually, answer. That's interesting. First REST mission was completely unnecessary. Uh, let's clear this mess. Yeah. I'm not really ill. I just, I'm not sure, actually. I don't have any allergy or anything like that. Rest. Yeah, well, the same. Yeah, that's not what you would expect. Oh no, is it another math problem? And I must say the difficult one because we've seen Max. Max did not solve it yet. He had like half an hour already. Why did I actually manually clear it? Yeah, I mean, it's expected that it compiles. It's problem F1, it has slightly higher time limits, so but not much. And this is just insane. It looks like some. No. No way. I mean, we can always use AdCoder library, but let's try to solve F actually. So given a positive integer n, you want to represent n as the sum of integers containing only ones. Not even zeros, which is important, but only ones. Or possibly negative. So that is kind of like zero, but you pay more if you want to get zeros. And you pay like a lot more. Instead of having around log n numbers, you pay actually log squared. Yeah, man, that's expensive. And like the problem is that I'm pretty sure that more or less this thing was somewhere already. Like I don't have any idea where it was. So that is a bit disappointing. Same time we have enough time, so at the same time we have enough time. I really should practice English because I don't use what is considered to be natural very often. And at most 50 suggests some DP, like really, like some digit DP, which is, at the same time, we don't have much choice, right? Is it actually beneficial to overpay? Hassan? Like, obviously, no greedy will work. Otherwise, it would not have been problem F, right? And what DP I'm actually talking about? I have no idea. Yeah, let me pause the recording because like it's not very serious either way. So I just think about it for a bit, maybe drink some tea and come back. So actually, like I was looking at the standings and I kind of realized that people tend not to solve F for some reason. I don't even know what the reason can be, like really. You can't tell, right? That it's just bad to have some digit to be. But I noticed that some people are solving G, right? And I looked at it and it really does not look like it has to do anything with FT or NTT, I should say. So I actually think it's about a different concept. So because here we have some string, some letters, and we given the frequencies of these letters, and we want to construct some good strings from them. And then we just want to compute the answer for this model. So the point is like, you have that very unusual constraint that HCI is greater than n over 3. And I am thinking that like there is not really a way you can use it besides the following idea of mine. That you, because of this, you can't run out of 3 letters at the same time. So like you are really concerned only with you can run at most you can run out of at most 2 letters. So you are really concerned with the frequencies of 2 letters. And the problem is like if you count how many pairs of letters there are and their frequencies, it's just too much, And transitions are like, if you want to do them like just the stupid way, and they are straightforward, and the stupid way does not work. So suppose that our DP state is like a previous letter, and then a current letter, right? So we can't bend previous because it will create, so the next is clearly not equal to previous because it will just create an obvious palindrome of length 3, right? But beside that, we don't have any constraints. We can even append current. And the reason for that is like because if you think about like what is a typical way to count palindrome substrings, like not the smart way with prefix function or anything like that. It's just expansion from middle. So like here we don't have palindromic substrings. So the only place we should care about is expansion from middle from here. But if our very first step of this expansion fails, then there's really not much we can do. Like there one palindrome. So we are really only concerned with prohibiting palindromes of length 3. And we are done. So because of that, the only context that matters are the 2 previous letters. Actually, now that I think about, current letter does not matter at all. We can get rid of current letter. We just care what is. Oh, but then like no. We want current letter for the transition. The transition will be to, yeah, we want current letter for the transition. For a second, I saw that I can just optimize it by dropping out, but clearly not. So for all next, which are not equal to previous, we have such transition. And it's one-to-one. There's really not much nothing smart here. But then we have like a problem, like what do we actually want to store here? Like we clearly want frequencies of these letters, right? And how do we store them? It's not clear. So we kind of want to know that at this point, the frequency of next is non-zero. And I really don't have any idea of how to do it, fortunately. That must be a difficult task. What do the standings tell us? So some people are solving F, but like really not many. And it's a bit more people are solving G, which is kind of one I think it's doable from here. Like the observation that you can run out of 3 letters can't be random. It's got to have something common with solution. Notice how we are slower than pretty much all of our friends, but at the same time we are a bit more accurate. So we evolve. For a moment, maybe they'll solve F or G. What it looks like very unlikely, a big jump in difficulty. Maybe actually the jump to G is not big, but you have to like commit to it, right? Because like most people just try to solve F and push through, I guess. Yeah, that's very funny. It's very funny. I kind of I just have to show it because it's just so stupid and so funny at the same time that I just don't know how not to. Yeah, so a friend of mine just sent this over Telegram. Yeah, if you're a Minecraft player, you know that diamonds can't spawn in groups of more than 8. Here we have 10. It's just clearly like not 10 separate diamonds, but still. I really think sometimes that I should have my notifications off. But at the same time, we kind of enter the stage when problems are quite difficult. So maybe it's not bad to get distracted for a little bit. Like the problem why I can't, I kind of wanted to store just frequency of previous and frequency of current. And how do you know where you actually go from here? You don't know. You need frequency of next to be non-zero. Frequency of next, like we clearly can't store the frequency of all numbers here in each state. Because then it's just too much parameters for a state. Like actually, 26n squared is as high as we can go. Like this is the limit, because 26n is 10k, and its squared is 10 to the 10th. And this kind of explains the 10-second limit. But you can't go higher than that, so you can't store frequencies of more than 2 letters. Which makes sense because you can't run out of more than 2 letters, but it does not make sense when you try to write DP. You kind of know, you have to know which letters you are going to run out in advance. It's really mad for me. I just don't understand how to do it. I just don't. Yeah, I guess it's kind of not very interesting to see messages syncing, so I will pause the recording once again. And maybe, just maybe, if I get some ideas, I will come back and comment on them. But that's unlikely. This is kind of difficult, actually.